Hello and welcome to our Tips and Techniques videos. I'm Mark Biasotti and we are currently in our advanced modeling episodes. And over the next 30 minutes or so, we'll be exploring how you can increase your skills using some of SolidWorks' more advanced features so that you can be more productive and create higher quality models. So whether you're a seasoned SolidWorks user or a beginner, we think that you'll learn something new in this series. For your convenience, we've listed the topics in the YouTube description that we'll be covering in today's episode, along with a timestamp for each topic in the video. Feel free to skip ahead to any tip or point you want to learn more about. This series is being brought to you by Spanner Product Development, a product development company dedicated to creating positive impact in the world, merging innovation, sustainability, and responsibility to bring meaningful experiences to life for over hundreds of clients. If you want to learn more about what Spanner has to offer, stop by our website at spannerpd.com or email us at hello@spannerpd.com. Now let's get started with this episode of our Advanced Modeling episodes.
Welcome to this Advanced Tips and Techniques series video. This is episode 12, Advanced Modeling Part 8, all about the sweep feature. And in today's episode, we'll be talking about all things that have to do with sweep. And these are some of the topics that I'll be covering in today's episode, mainly introducing you to sweep and how it can be used, talking a little bit about the property manager of sweep and some of its options. We'll then move into some more complex sweeps, namely 3D sweep and using guide curves. And then I'll move on to some practical examples of how sweep can be used in product design. And then I'll finish out with how to get around some of the problems that you might be having with sweep, namely self-intersection and twisting issues. So let's get started with talking about what sweep can be used for. So as a matter of review, we can talk about how sweep is used and where it is most useful. We've talked about the boundary and fill and how it's used in previous episodes. Sweep is used when you want to create a shape that has a general or very similar cross-section through a path, or it has a general shape through a direction. And that cross-section can be constant, going along a complex path, or it can be varying, going along a complex path or direction using guide curves to vary its cross-section as it goes along the path. So these products here would be examples of how that's used. In the game controller on the left, a profile is created at the base and then swept up to the top to create the complex grip area and trigger area. Quite likely there would be some guide curves to alter that profile as it moves along the path to get the shape that the designer wants for the actual handle area of the game controller. The handle on the door in the middle example is just a circular profile that's swept along a path, and then guide curves are used to bring it down to a point at the end of the handle and terminate it. The faucet on the far right would probably use 3 different sweeps, one for the spout, which would be profile in path 1. The valve base that extends upward would be the second sweep, path 2, using profile 2. And then the actual handle on top would be an additional sweep using a profile in path 3 to create that. So why don't we talk a bit about these features with some SolidWorks models that I'll bring up, and I'll do that right now. Let's start out with this sweep example which is fairly simple and uses a path and some guide curves. I'm going to delete the existing sweep feature, and then we can take a look at how it was created. So we'll show our sketch curves. Let's hide our planes to make it a little more clear. And as we move up the feature manager, generally unlike other features in SolidWorks, when you're creating sweeps, you usually want to start by creating the path and profiles first. And so here in this sketch, I have two curves, one that represents the actual path of the sweep, and the second would be a guide curve for the sweep. And as we move down, we add an additional guide curve up here between the two. With those created, then we create our profile. The reason for that profiles are generally created last, is that you want the profile to be driven parametrically by the path and its guide curves. So you can see in this sketch that we have a Pierce relationship on this upper guide curve with our profile, and then we have coincidence relationships with the path and a coincident relationship with this other guide curve. So with that, we can actually alter the shape of this profile as it goes along the path, because we have these relationships with the profile. I've created a few other constraints here to fully define it. And so now we can take that profile and we can create our sweep. So with the profile selected, I'm then going to select the actual path, and our selection manager comes up because we have two sketch entities in this single sketch. I'm going to select this one, and now we have a preview of what this would look like with just the path and profile. We want to keep going, however, to add some more shape into that, and we're going to do that by selecting our guide curves. I'm just going to keep our selection manager up, and I'm going to pick this curve. And you can see the profile then, or I'm sorry, the preview then updates to show you what that would look like. And then I'm going to add the second guide curve on top, and then we can complete our feature. And if we show our tangent edges here, you can see what's happening. So that single profile is creating a very complex shape given the path and the additional guide curves. That's generally how the sweep feature works for us. Let's move on to a bit more complex example of how to use sweep, and that would be with sweeping along a 3D path, as is the case here. We have a path that is created from a number of 2D and 3D sketches to create a closed loop. We're going to take and create let's just say, for instance, this is the gasket that has to cover the opening of a pipe that isn't planar, but it dips down here. So we're going to create a sweep, and we'll use this as our profile, rectangular profile, and then we'll use this as our path for that gasket. So you can see that immediately we get a preview, and if we complete that, we get our general shape for the gasket. Now there's a few problems here in that we want our gasket to namely lie flat as it goes around the opening of our valve opening. So let's go back into the sweep and check out a few more options. So here under options, we're going to follow our path. We're not going to keep it normal to constant because that would be geometrically an impossibility to take this and keep it going normal to constant, because if it did, as it moves along this path, it would mainly self-intersect in these areas. That's not the solution we want. Right now we have minimum twist on, which is usually the default in SolidWorks. If we go to natural, you can see what that looks like. A bit weird, usually not preferred. In some rare cases it is. So we can also specify a twist value, and what that means is if you have a profile that you need to twist along a path, you can actually enter a number of degrees, let's say 720. And what this is doing is it's taking that profile and twisting it as it goes through the entire path by a certain number of degrees. That is not what we want here. So we are going to drop down to our third option, which is specified direct vector. And what specified vector does, you can see that I've created a little construction entity here in our y-axis. I'm going to pick that. And now that I pick that, it helps me to orient this gasket the way that I want it. Now without it, what is apparent here with minimum twist, what we see there is that we have this at an angle here to start with. If I wanted to keep that angle at 24 degrees constant all the way around the opening or the path, it doesn't quite meet that requirement. You can see with minimum twist it starts to flatten out here. If we use specified direction or vector and pick this as our vector, then you can see that what the profile or sketch is doing is it's using this sketch entity to keep its orientation constant as it sweeps around the path, and it uses this as the direction. So that's closer to what we really want. We can take, and if this is not at an angle, we can edit that sketch to make it basically 0, and then rebuild. And you can see that we get something now that looks like what we actually need for that gasket. But there are some cases, even with using a vector direction, that it's still not getting to what we want. And if we go to the top here, you can see there's a certain amount of twisting going on here, which really doesn't translate to being a kind of a planar sweep around as it goes and meets the opening. So in some cases like this, we would probably have to give the sweep more information. So we're going to rebuild this using a guide curve. And what I've done here, if we move forward in our feature manager and look at this trim surface, I basically extruded a surface in this direction using this sketch entities, and then I've trimmed out the inside to give me an additional guide curve path here on the inside. So now with this additional information, we can take our profile, we can reorder it, and then reconstrain it so that we get something that we want. So I'm going to take this point and pierce it with this edge. And the reason it's over constrained is that we need to make this a driven dimension instead of driving. And then we also have to do the same for the angle. So now, instead of the angle and the dimension, the width driving it, we're letting this additional guide curve drive it. So as we complete our sketch, we'll create another sweep. Let me do a solid sweep. You could do it surface or solid. I'll pick this as my profile. I'll pick this as my path. And then I'll drop into guide curves and pick this edge. Now we have to use selection manager because there's multiple edges here. And we're going to gather them up with the helper. And then we'll complete our sweep feature. There's a few other options here. You can merge tangent faces, which means if there's any tangent faces that are created by the actual sweep, it'll merge them together. Show preview sometimes is helpful if it's a complex sweep. You can turn that off while you start to adjust some of these parameters and then turn it back on. And then merge result is merging it with an existing solid body. Now, tangent start and end really don't apply here because we have an open or a closed loop, and the start tangency is the end tangency. And if we do it path tangent, you're really not going to get any different result. And then of course you can do a thin feature. If you're doing pipes and whatnot, you can make them thin. So let's turn that off and let's make these none. And to finalize this, you get some evaluation tools down here. You can display the mesh, you can display curvature, you can increase the mesh size, you can put combs on it to see what it's doing. And we're going to turn that off right now. But what results here is, if we hide our surface, now we have something that is more like we predicted it would want to be as it sweeps. You can see it's very constant as it sweeps around. And so that's how you can use directional vector, but also additional guides to make shapes like this. So I'm going to move along to show how sweep can be used in a practical way for product design. In this Shaper Tools shaper, the two handles were created using sweep. And if we bring up this model, or at least the handle part of the model, I'm going to show how sweep can be used to create a very sophisticated end cap shape. And so with these current sketches, I'm going to start to select my profile and then my path and guide curves to create that. So let's do it as a surface. So we're going to specify a surface sweep, and we're going to use this profile right here as for our sweep. Now currently this is constrained, this curve is constrained along these additional guides, and then we're going to select the direction or path. So we're going to create our path using this curve, and here you can see that it's chosen an arbitrary direction. If you don't use guide curves, you can reverse that, or you can use both. In this case, we're going to be using guide curves. So as soon as we pick a guide curve, those are going to disappear. So let's go ahead and pick this guide. And you can see immediately it starts to conform to the guide with the profile. We're going to continue to add them. And as we continue to add them, you can see that we're getting some conflicts. So a way to avoid those conflicts is to use the selection manager and be more explicit about what you pick. So let's cancel out of those, bring up selection manager, and then start to pick them using selection manager. So I'm going to drag this meatball back to this point and give it some additional information. I'll do the same with the second and third. Let's pin our selection manager. And then bring this back here. And let's do it again with this one. So now what you can see is a very powerful result, and that's the fact that SolidWorks Sweep is able to sweep down to an infinitely small point or 0 with the path. So if we complete that, this is what we get. Very high quality surface. I prefer to use this solution over boundary because you get a higher quality surface. This surface will never inflect because it's being created conically as it moves down the path and then is directed by the guide curves. To do the second half, it's a simple matter of just creating a second sweep going in the other direction. And we're just going to repeat our steps to create our sweep. We're going to again use the existing profile. We're going to use the existing path. And in this case, I'm going to actually pull it in the other direction instead of using these controls. I think what I'd like to do is use our selection manager to then define which way I want the path to go. So I'm going to use that instead. So with that path, and you can see the reason it's not completing is I overshot. So let's go ahead and edit that and then pull back to this point. You can see I also selected just one half of this profile. So in here, I'm going to clear that and just use the entire sketch. So now we have our profile and we have our path. And then again, we'll use Selection Manager to be explicit about what we select. Now you don't have to pull back. You can just generally pull back so it knows the direction. And then do the same for the others. And then our third one. And then complete. And so now we have our solution for the end cap. It's a great way to use Sweep for this kind of application. Now you might be wondering, how did I get what looks to be C2 across the two sweeps without defining any start-end direction? Well, in this case, it just happens naturally because even without any start or end tangency, you have to remember that the profile is following the path and guide curves for its direction. So these curves that make up the first and second sweep are one and the same. So they're going to equal each other across the boundary between the two sweeps, and that's how that can allow that to happen. So that's using sweep with guide curves and sweeping down to a point. So here's another practical application for sweep. It's very similar to what I just showed, but you might have remembered this digital tire pressure gauge from the episode that we talked about fill. Prior to that fill, I had created one half of the rear handle for the tire pressure gauge. And this is done the same way with the sweep. And if we delete that feature and then recreate it, you can see that we have our profile. So we're going to take that and we're going to sweep that profile along this path. And again, let's use Selection Manager so we can be more explicit. So there we have our profile and our general direction along the path. And now it's just a matter of adding some more information. We're going to pick this curve, and then we're going to pick this edge, and complete. And so you can see that you get a very nice result using this method. And again, I contend that you're going to get a better result using this than you would boundary. just because of the way that it's being created using Sweep. My final example for this episode to introduce you to Sweep is to show a more complex way, even more complex than the previous examples, of how you can use Sweep to create your features and your complex shapes. So this is an existing product. It's this product. It's the Woolly Pocket wall planter. It's a indoor and outdoor wall planter that self-irrigates and can be used on fences or walls, either singularly or in combination with others. And if we go back to the SolidWorks model and how this is created, so this took a number of different experimentation passes to figure out how to do this. It was first tried with boundary and loft, and really couldn't get it to what the industrial designer wanted it to be, and that is a very continuous form. But it's a very sophisticated form because as this surface moves around its perimeter, this edges or this attack angle from the base is constantly changing. And you can see it's very shallow in the front and it's rather steep in the rear. But it does fit into the definition of a swept type feature because the general profile is similar as it goes around the path. And if you consider this or this edge right here as the path, or even the top edge as the path, that's generally what it wants to do. The problem was how to get the actual profile to be dimensioned or parametrically driven to create this attack angle. And so what was done here, if we roll back into this feature, I can show you. So we're going to show all of our sketches and maybe even some planes. Let me give that another try. Okay, so I'll show the planes too. So basically what we've done here is we've created a number of paths and guide curves. And here we have the top of the planter, or at least one half of it. We have kind of the midsection profile, and we have the bottom section profile. So that's our top guide. This is our bottom. And then there's our mid. Now, there's an additional one here, and this is kind of the key on how it worked, is that we created just a reference guide curve down here. And the reason that that was done, if we show that and then roll down to our actual profile. Now, if we look at our profile, the profile is made up of a single curve. It's a fit spline. If we delete the fit spline and take a closer look at it, we basically have a line because we want the top to be pretty much a ruled surface. And then below that line, what we have connected is a conic. And I've spoken about conics before and how I really favor using them because they can be parametrically driven. In this case, I can drive it with a single row value. But at the end, where that, remember I mentioned where I want that angle to change towards the base, I have another construction curve that's driving the end tangency of the conic. And that construction curve is being driven by this reference curve at the very bottom or even below the base. So that's how I've constructed the actual profile. Let's get back our fit spline. And so I fit splined a single spline entity over those two, that conic and that line. And so if we look at our actual sweep feature, what we have is we have the profile that I just explained. I have our upper curve, the top of the planter, as one of the guide curves at the top. The path is actually right down at the base. We have a second guide curve here, and then we have this helper guide curve. And this is really the key to making this all work, is that even though I'm not using this in the surface, it's actually driving the profile to give us the shape that we want. So with that, it's able to actually change the profile as it sweeps around its path and do it in a very sophisticated way. One thing I failed to mention earlier is Sweep puts in a little diagnostic tool here. So this little eyeball, if you view that and then step it through, you can see how the path is actually being created as it moves around. I'm sorry, the profile is actually being created as it moves around the path. This could be a very useful tool because at some point, if your sweep feature is not working, this is going to stop working as a diagnostic tool. It'll just stall at a certain point. It'll stall at the point where it either stops making a sweep or not at all. So that's very useful. But in any case, if we complete this sweep and we hide some of our reference, you can see how smooth that becomes. If we turn on curvature, you can see it's fairly good curvature. And if we turn on zebra, we can also take a look at it that way. So yeah, it's just a great solution for using sweep to create these kind of shapes. Now, sometimes you might experience problems using sweep where you've created your profiles in your path and maybe your additional guide curves. You've tried to sweep it and it just fails to sweep. And it may come back to you with a diagnostic message saying this self-intersects. That's usually the case when you have a profile you're trying to sweep through a path and maybe an additional guide curve, where as it goes along that path, the profile itself actually self-intersects, and that's what it's trying to tell you. Now, SolidWorks is pretty intelligent because even if that's the case, sometimes it actually will create the geometry. In the case of these profile and paths, if we create this as a sweep using this as our profile, and then using this as our path, you can see that in some cases, especially where the path has sharp corners or vertices in it, it can actually resolve the corner. And if you think about it, as this profile is being swept along, it's actually overshooting this corner and then moving back on itself. So this would be a valid example of self-intersection. But in this case, SolidWorks can resolve it, and that's quite useful. I'm sure furniture makers love this feature for simulating routing around corners and whatnot. We'll just go ahead and complete that and then keep moving down. But that's one case. In a lot of other cases, it doesn't work. So if we have, for instance, this is our path, this is one of our guide curves, and then we have this as our profile. And it's basically just a little arc, going to create a surface. And we start off with using a swept surface. And then we'll use this as our path. And then we'll use this as our guide curve. Now, because this is a surface, it will probably complete, but we'll see the problem. So here we see as the profile is being swept around the path, it stays normal to that path. And when it gets to this point, it still wants to intersect with the guide. And so there's a bit of pinching in the surface here. Now, I'll bet I can get this to fail if I go in on this curve right here, which is hidden. I'll show all these. And we start pushing around this point. So if we take this point and just make something like this, you can see that our sweep fails. And it's not noticeable immediately, but when you try to complete it, it's going to say that it's self-intersecting, what I mentioned before. Now our diagnostic tool will help us with that. So as we start moving this around, and you can see that unfortunately the diagnostic tool is not going to work here because the increment is too coarse. So even on my first attempt of moving, it's not going to give me a preview. So it's pretty apparent though from what I've done here that it is self-intersecting. So it's just a matter of using a guide that is more regular or is smoothed out. So if we go into this profile and instead of using this as one of our guides, we're going to stretch this out and we're going to make this our guide. And then go back and edit our sweep feature to include this as our guide. So there we have something that's more acceptable, more predictable. And if we go in and take a look at it, you can see how things are working here. And here's the diagnostic tool. You can see as it moves along, we can see that it's generating in a full loop. So that is one thing to watch out for, especially when you get the self-intersecting message. A second issue that can come up with sweep, especially if you're sweeping along a 3D path, is a twisting problem or a non-consistency problem of the profile as it sweeps along the path. You can see in this model that it's pinching quite severely here, and even down here in this third area. And what's happening is that the path itself is made up of multiple entities, and as the profile sweeps along that path, when it comes to a vertex in that path, it doesn't know what to do. Is kind of the best way I can describe it. So my solution for that, and this often works, is to try to simplify the path. So let's do that. Let's go into our sweep feature, take a look at our path. Now this path is made up of a number of 3D sketch curves, and they're all separate entities. They are tangent with one another, but for some reason the sweep feature has a problem with it because it is multiple entities. So what I often do with 3D paths is I simplified the problem for sweep by making all of these one entity. And you can do that with the fit spline feature. So I have it on my shortcut key because I use it a lot. So I'm just going to pick this chain and fit a spline over it. And bring the accuracy up a bit. And now that we fit a spline over that, voila, we have problem solved. And namely, it is just sweeping along that single spline, and it can understand much better how to migrate that profile along the path. So with that, you can also add a directional vector to correct the problem too. Let's show that. Actually, let me just create an axis between these two. And let's roll that to the front of the feature manager. And now if we edit our feature, we can use our directional vector option to slightly improve our result for the sweep itself. So there you have it. That's how to overcome twisting problems.
Thanks for tuning in to today's episode. We hope what you've learned has been informative and can help you to better use some of SolidWorks' advanced features. You'll see in the YouTube description a link to example models used in today's video. Feel free to download it, and you can explore these techniques at your own leisure. Also, we'd love to hear from you, so consider emailing me at the address you see here on the screen. If you need help on your design project or just want to know more about us, stop by our website at spannerpd.com or email us at hello@spannerpd.com. Take care, and I'll see you in the next episode.